So with this problem, we've got our rod here. It's pivoted about this point, 20 centimeters from the end. We've got F1 here, F2 is here. Then this point here is also 20 centimeters. From the pivot point, we've got force F3 and force F4, and then we've got force F5 at the end here. And we know that the torque is given by R cross F. And in this case, all these forces have the same magnitude. So we can write this as RF sine phi, where phi is the angle between R and F. Okay, so torque 1 is going to be equal to the 20 centimeters times the magnitude of the force. So R1 goes this way from the pivot point to where the force is. Force 1 is at 90 degrees to that. So this is going to be equal to RF. Now torque 2, there is no distance between where the force is applied and the pivot point. So R2 is actually 0. So torque 2 is going to be 0. This doesn't apply any torque. Torque 3, again it's 20 centimeters. So it'll be R, where R is 20 centimeters times F. And like with force 1, the angle between R and F is 90 degrees. With F4, you can see that this angle is greater than 90 degrees. So sine phi is actually smaller for force 4. So torque 4 is going to be less than torque 1, which will be equal to torque 3. And torque 2 is 0. Now torque 5 is also 0 because the radial vector in this case is in this direction, the force is in this direction, and so when we have the radius and the force parallel, the cross product's 0. So torque 5 is also 0. So we can say torque 1 is equal to torque 3. They are greater than torque 4, and that's greater than torque 2, which is equal to torque 5, which is equal to 0.